if there's one thing you're going to get out of this lesson and doing these kind of questions, it's going to be being able to draw these fancy squiggly brackets. Okay, that's what we're going to learn how to do today. Squiggly brackets. I don't even know what you call them. I'm sure they have a name, but the domain of a relation is the set of, well, I think we kind of learned this already yesterday a little bit. It's the independent variables, okay, which is the x values. And the range is talking about the set of dependent, which are the y values. Sorry, I'll try to be neater. There's no reason for me to be messy. So we want to be able to determine, and I think some of you already did this a little bit yesterday, but today we're going to formalize actually looking at a graph and figuring out what the domain and range are. Okay, so yesterday I think it was kind of a nice little intro in terms of what's the domain. There was a question about, there was like people's names, and in the answers we saw it was like Brenda and Darlene, and that was the domain because that was the independent variable. So nothing's changed since yesterday. We're just going to look at, here's a series of points, okay, for a relation, and we're just going to look at what are the possibilities for the domain in each of them and the range. Okay, so for this you're going to write the domain, and here comes your first opportunity to show how you draw a squiggly bracket. I'm still not too good at them. Okay, so inside of this fancy bracket for domain, we're just going to list all the independent variables, or the values, independent entries, right? So for this, if I'm looking at this, we're going to go, okay, there's an x value, there's an x value, there's an x value, there's an x value. So your domain for these points are like what values of x exist if I had these on a grid. Well, -2, -1, 0, 1. Okay. Anybody have any questions? Not too bad. Okay. They get a little trickier when you actually have graphs, and I'll show you how that works in a minute. Okay. The actual ordered points or coordinates or relation, those aren't too bad because you're just going to list the entries. But so the range, we're going to say, are the opposite. It's all the y values, -5, 10, 15, and 20. Okay. All right. This one here, this is actually almost I think this is the exact same sheet as yesterday. We're just looking at different stuff today. Okay. So we're looking at, for the domain here, here's the catch. You're only going to write, if you have multiple entries, you're only going to write it once. Because you can't, why would you write the same x value twice within a set? Okay, so you're going to have 0, 1, and 2 for the domain. And then for the range, we're going to have -1, 1, and 2. Does that look like correct, everybody? Okay. Now, if I have a series of points, like what I have here on the grid, same idea. You could take all those points and write them in a list and then just state whatever the domain is, state whatever the range is, same thing. Where things get a little bit more interesting is like, let's say, D, E, F, and H. Okay. So for C is very much a continuation of A and B, with the exception that they're not listed for you. So you're just going to look at them and read off basically for the domain. And maybe I'll start doing this in red, just for no particular reason other than to denote the difference between the x and y values. So for the domain here, we're going to see, okay, what's the x? I just like starting at the lower side and then just working right. So the x value of that point is -3. The x value of that is -2, then -1. I don't see any points at 0, so I don't write 0. Skip over it. You go 1. It looks like at 1 we have 2 points, but you don't write this, like any particular x entry twice. So it's just 1, and then 2, and 3. Oops, that's a little close to my squiggly bracket. All right, does anybody have any questions? It's just all the X entries. All right, and once you've done X, you can do the range, which is the Y. So erase your marks here. Go again, right? Y, I don't know, you start low and go high, I suppose, right? So looks like my lowest Y value entry is going to be that -2. So I'm just going to start there. And I do that so that I don't miss any, right? You just catch all the entries. So I know I have -2. I might run out of room here. -1. Again, nothing at 0. So skip over it. You've got 2 entries at 1, 2, 3, and 4. So are we happy? Did I miss any? We're okay? Okay. Lots of nothing too crazy going on there with that so far. Okay. Now, we do have kind of a fancy way to write these domain and ranges, especially when they're like a continuous graph. Okay. And I'll write it down once or twice. We'll do a question, then I'll explain what all of it means in words. Okay. So for D, okay, a circle. We already know D's not a function, so it's like state the domain of this particular relation because it's a circle. It fails the vertical line test, right? So the domain of this, here's how I do this, and I think this is how I've been most successful in understanding this. You look at the high and low values for the domain. I like drawing kind of just a vertical line here because I know at no point does that circle ever reach any x value less than -3. Would everybody agree? So that's what I consider my lower boundary. I never have an x value go lower than -3. At the same time, I can go to the other end of the circle and I can say, well, I never have an x value that goes above +3. Everybody agree? Those are, you don't need to necessarily label those. I'm just doing this for just to help us visualize. Okay, and then so that's our domain in red. So you could say, I'll draw the other box here in a sec. So on the other hand, if I'm dealing with the range, which is in what's in blue, I know I never have a value that goes higher than +3, and I know I never have a value that goes lower than -3. Would everybody agree? That's me contained the entire relation there. And I suppose that's what I try when I look at something and I'm trying to determine the domain and range. That's what I'm trying to do. I'm trying to like determine what values are the boundaries, right? Low and high. Sometimes you don't have a boundary, and then we'll see an instant like the parabola in the next question. Okay, and I'll show you how to write that. So, albeit that this is not a function, it's a relation. Would everybody agree with the fact that at any point along here, I have an infinite number of points that comprise this circle? Would everybody agree? Because it's a continuous graph. Would everybody agree with that? So I can have any value of x and any value of y as long as they both fall within that box that we've drawn. Would everybody agree? So I could have 2.67 and whatever it would be the corresponding value, or like whatever, right? So there's an infinite number of x values in that domain. Would everybody agree? Okay, so to write that, we're going to say something. Let me switch colors here. The domain, we're going to open our bracket. We're going to say that x can take on any value as long as it's a real number, right? So you're going to write something, and I'll explain what each one of these symbols mean in a second. So you're going to write something like this: x, e, r. Okay, that e is the epsilon. I'll explain in a sec. Okay, such that I'll explain this in a sec. Can we see that okay? So remember the other day we discussed what that double bar r meant? That was the like entries that are real numbers. Okay? And then we say that x x has to be greater than or equal to negative 3. Would everybody agree? And it also has to be less than or equal to positive 3. So that's how I write my domain for this particular graph. Okay, the relation. Sorry, I'll get rid of that because I don't think I necessarily like the pink on the red. Does everybody see how we've written that? Yes?
So does it need to be more than positive 3 and less, sorry, more than negative 3 and less than positive 3?
Yes. Yeah.
Wrote this down.
Okay, so the way I read these, okay, I'll always, when you have multiple, remember inequalities from grade 9? So sometimes in the inequalities in grade 9, we stood in the middle and we read outwards. Right? So I stand in the middle. This is the easiest way to write this, so that you don't have to write it 2 or 3 spots. I stand here in the middle, and I read x is greater than or equal to negative 3, and x is, then I go back to my standing position, x is less than or equal to positive 3. Have you see that? I write it like that because it always looks like this. It's always, it always reads as less than equal to, but you never make a mistake. The orientation of those two signs is always facing the same way, and you just throw the upper and lower boundary on either end. It's honestly the easiest. There's no less. I try to promote as little thinking on the stuff that doesn't really matter. It's not that this doesn't matter, but just like you have other things that have to like use your brain power on. So wherever possible to provide just one kind of stock thing, I try to do that. Does that make sense? So those two like greater than equal to signs should be just facing the same direction. It's not that you couldn't flip these around and put positive 3 here and negative 3 here and then do this. You could do that too. It's just I just like having the left to right kind of reading. Okay. It's a good question. That always comes up. Okay, stand in the middle, read outwards. But the nice thing about this is you're always going to write it like this and put your upper boundary here and your lower boundary here. Question, yeah?
Why are those the like greater than signs the same? Just wouldn't it be different because if we're saying x is less than or equal to 3, so wouldn't it be the other way?
That's what this one's saying. X is less than or equal to positive 3, right? So again, there are probably multiple ways to write this. I just want to give you one stock way to do it so that you write it the same way all the time and it's never incorrect. Right? And you just put your upper boundary on the top half and your lower boundary on the lower half. Yeah?
What if you wanted to write 2 conditions, like x is equal to some function and it's less than 3, for example? Like if you wanted to put 2 conditions.
You could. I just like.
How would you write that?
I don't know. I'd have to think about it. I just like having one statement. Done. Right? Move on. It's got your domain. So you can be done. Right? Is everybody okay with that? We'll do the range just to lock it in. Okay? And then after I finish this question, I'll explain what each of these symbols kind of mean so that when you look at a domain and range, you kind of understand what these symbols mean and how like you don't want to have to write this whole sentence all the time. This is why we've put those labels there. Okay? So the range, conveniently because it's a perfect circle, is the exact same as the domain, conveniently. But that's not always the case, right? So the range here, the range goes from just be careful. What are we talking about this time? X's or Y's? What's range talking about? It's Y's. Same idea here. You can have any value of Y as long as it's contained within those 2 blue bars. So it's Y can be a part of the real numbers such that, again, lower boundary, negative 3, less than or equal to Y, less than or equal to upper boundary. Done. I don't think at any point anybody can argue what you've written down there, which is why I just like having one stock way to do it. Okay? It's not wrong. Are people going to have different forms? Yeah. Right? Different preferences and things. IB could very well have its own thing, but I just found for you getting into this, it's the easiest way to do this. All right? Now, because the black, oh my goodness, can you tell it's Friday? On the back of this, because it's blank, we could do something like this. If I write a statement like this, like what I had just had above, X is obviously talking about the independent variables. We don't need to really write anything like that. E, or epsilon, I like to read, this is what I'm reading when I look at that statement like that. Okay, are we following? So X, the little epsilon, just a bunch of words, right? This is why we don't want to have to write this huge, big, long sentence every time we write domain and range. So we should kind of like abbreviate it, if you will. Okay. X is a part of the real numbers. Draw a line such that, just a vertical line, and then put your conditions, lower and upper boundaries. That's what I read when I look at a domain range. X is a part of the real numbers such that, here's my lower boundary, blah, 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 lower or less than or equal to, or sorry, greater than or equal to lower boundary, less than or equal to upper boundary. Does that make sense? That's what I'm reading when I look at what I wrote down there, okay? In terms of a sentence. All right, so what I'm gonna do now, are we copying that? Almost done? We'll go back and look at that quadratic there, okay? That parabola. And we'll try to come up with the domain and range that represents that particular graph. Alrighty. Let me go back up. So we're going to look at this domain. In theory, I'm going to add these because they're supposed to be there. They must have been cut off. That quadratic or any quadratic goes on forever unless it's like been determined not to, right? And so that means forever, that graph is going to continue to increase in the positive x direction, and it's also going to continue to increase in the negative x direction. Would everybody agree with that? Not by much per like step, but it is increasing in both horizontal directions. Would everybody agree? So your domain here, we don't have a limit on our domain. I can't draw those boundaries on that graph. Would everybody agree? Because it's continuing in the x direction in both directions forever. So I don't have any upper and lower boundaries. So then you might ask, well, how do I write a domain for that? Well, if I don't have any boundaries and it's a function, or a relation, I suppose, and it can take on any value of x, then it's XER. It's x can be a part of the whole, like all the real numbers. So our domain for this one would be XER. And you're done. Because there's no limit to it. Yeah.
You just write R.
Yeah, like the remember yesterday we did those real numbers? It's a double, like a double bar.
I mean, can you just write like the domain is R, like just the set of your.
Oh, I suppose. Yeah, you could do that as well. I don't know. This is what I got shown a long time ago. It's just, this is, I don't know. It's just stuck with me. There's all sorts of different ways to do it. I think if you went online and looked up domain range, you'd probably find all sorts of stuff. But I could check with Farahani and see what she wants to do. The range, what's the catch here though? Be careful with the range. Is this graph continuous? Like, I could have any value of y with the exception of what? I know it's not particularly clear. We'll call it. No, I'm not gonna. On the test, obviously, I'd be very, very clear. But yes.
It can't be smaller than like -2.
-2. Call it -2. Okay, so we'll say At no point does this graph ever reach any y values lower than -2. Would everybody agree? So let's just write our range like that. Range is going to be y-er. It's still true that it can be any part of the real numbers, but here's the condition, such that y has to be greater than or equal to -2. Now there, I don't really particularly care whether or not you put the lower boundary or not. Like how you write this, like you could have written this piece as -2 less than or equal to y. Okay, you just gotta be careful with the orientation of things and making sure that your sign, your inequality sign there, matches what is actually going on in the graph. Okay, are we happy? What you'll find is the quadratics don't really ever have a restriction on their domain. If it's just a quadratic graph, it just goes on forever in both. So as you do a few of these questions, you'll start to recognize the fact that the domain for a quadratic is typically, unless I try to trick you, which I probably won't, is always XER. Right? It's a part of the real numbers. Okay? And then you just got to figure out, you know, what's the boundary on the y or the range. Okay? Jumping down, if I could just do one more here, like quickly. Maybe I'll stick with you for another few minutes after break here. The line, these are arrowheads. Do you have any restrictions on the line? I don't think there's any restrictions on a line, so you're going to get domain is going to be XER. And the range, YER. Okay. I'll hit stop there and we'll finish.